Hello, hello and welcome to this video. We had studied Postgres documentation till pattern matching, and the next topic that is which we had to study was pattern matching. That is the discussion about patterns or regular expressions in PostgreSQL. So pattern matching is best understood through practical examples. We will go through the documentation, of course, but I wanted to show you what you can do with regular expressions. And so I have prepared this file where we can see what we can do with regular expressions. Okay, we will probably take two videos to cover this entire file, and then we will move on to the theory side of it. So without further ado, let's get started. First, we have some operations. Tilde or tilde, this character, it does case sensitive regex match. When combined with star, we do case insensitive match. If exclamation mark is before this, then it is case sensitive non-match. And if we have the combination of all three, we do case insensitive regex non-match. It will become clear as we see examples. We will use certain functions: regex matches, replace, split to array, split to table, and substring from regex. Certain shorthand characters are there, or tokens, which have special meaning in regular expressions. You might have studied these in other languages as well. So if you are from Perl, you will certainly know Perl, Ruby, PHP, Java, C++. Almost all languages have regular expressions. Either they support POSIX or they support ECMAScript regex or JavaScript. So for example, C++ uses ECMAScript regex, and Python, I believe, is quite compatible with the Perl side. PHP is also Perl side. Ruby will be also Perl side. C has a PCRE library. So these tokens have typically same meaning across all these languages. We have caret for marking the beginning of string, dollar for end of string, dot matches any character, star means 0 or more, plus means 1 or more, question mark is 0 or 1, brackets define character class, caret in the bracket uh, shows us negated character class or defines negated character class. Parentheses are capturing group. Pipe is OR operator or alternation in Postgres. Backslash D is digits, that is 0 through 9. Backslash capital D is non-digit. Backslash S is white space. So what white space constitute of is a single space bar. You have tab, you have enter, backslash N. You have vertical tab, line feed, uh, vertical tab, line feed. I believe these are all the white spaces. Then backslash S is non-white spaces. Backslash W is word character. Word character, I'm not sure the meaning of this by backslash W. Typically it means alphanumeric character 1 through 9 and A to Z, capital and small. And backslash W is a non-word character. So with these we start the examples. I think we can finish this today. Let's see. So we have select, and then we have hello 1 2 3, and then we have the matches operator, and we have 0 to 9 plus. So our character class is 0 to 9. That is, it should be one or more uh, values of 0 to 9. So it will match 1 to 3. Okay, and there is no beginning or end marker, so yes, it will match, and it is true. So on Postgres prompt, if you want to run this, you select this query and paste it here, and it will also give us true as output. So I'll be showing everything on Postgres. Alt tabbing is pain. Then if you want to do case insensitive match, you can do tilde star. This hello has capital H, this one has small h. So it will match because case insensitive is good. So that is true. Let's move it a bit down. That should be enough. Then we have case sensitive non-match. Hello is there and it is 0 to 9 plus, so it won't match. One or more digits will not match with all alphabets. That is also true. Case insensitive non-match. Hello will not match with world. Then we have basic pattern matching. We have PostgreSQL, and caret means beginning of string. So beginning of string is here and post is there, so it will match. And then we have PostgreSQL. We have SQL dollar. So end of string and it will match. Then we have contains substring. So you can give any string here which will match with the between stuff. Don't give caret or dollar here and it will match. Then we have exact match. So suppose ABC123 is here, then you give both the start of the string and dollar and it will match. It will match from beginning to end. Then we look at character classes. 1, 2, 3, 4, 5 is here. Caret will start at the string. 0 to 9 will plus will mean this should be made up only of digits. Plus means one or more, and dollar is end of string. So that is also true. Then we have small abc, capital DEF, start to end, that is caret and dollar. And then our character class is alphabets, capital A to Z, small a to Z, and plus. So it will match. Then we have ABC1 to 3. We add another character class 0 to 9. It will match. Then we have white spaces, one or more. So we have spaces here. So backslash s plus beginning to end. It will match. Then we have ABC non-space here. So it will match. Then we have user underscore 123, which is word character. Underscore is also included. Alphabets are all included. Then we have non-word characters at the rate, hash, dollar, or other symbols. Then we have a star. So 0 or more, we have 4 A's, match. We have a plus, 1 or more A, it will match. Then we have color. So COLOU. And then question mark means the original string should have 0 or 1 U. 0 or 1 U. So it will match both the US as well as English color. Then we have 1, 2, 3, 4, and it is n times match. So beginning to end string, it should be made up of only 0 to 9, that is digits, and they should be 4 in count. So any 4-digit number will match this. Okay. Then we have m and n times. So m and n means between the range. So this will match 3 to 5 digits. All right. So it will match. It will also match any 3-digit number. Then we have at least n times. So this should match any integer greater than 3 digit. So it will match all numbers other more than or equal to 100. Okay. Then we have or tag. So it will match cat or dog. Then we have grouping here. So we use the function regex matches here. And we have 2025, 05, 29. So first we have 0 to 9 and then we have the multiplier. So 4 digits minus 0 to 9, 2 digits minus 0 to, or hyphen rather, not minus, 0 to 9, 2. So it will match the date because it is 4 digits, then 2 digits, then 2 digits. So we run this. So you see what happens when you capture groups. They come as an array. Then we have ABC 1 2 3 XYZ. Similar to previous one, we have A to Z plus 0 to 9 plus and A to Z plus. So it will match a string with alphabets, digits and alphabets because plus is used. So one of each type must be their minimum. So we have that. Then we have regex functions. So regex p matches is similar to tilde operator, but it will give you the output in array if you use parenthesis for capturing the group. So you know this regex p by now. And then we have cat dog word, and it will match w plus. So in globally, so it will match cat, dog, and bird 3 times, and they will come on separate column. W plus means word characters, alphabets, numeric, and underscore. So first it matched cat, then space, it won't match space. Then we have dog, which is W plus. Then we have bird, and G means over the entire string. Regex P replace, we have ABC 1 2 3 XYZ. So it should be of 3 digit. So it is a token pasting stuff. It replaces the string. 1 2 3 is replaced by hash hash hash. So the format is original string, regex, and replacement. Then we have another replace 1 2 3 4. It should match 0 to 9 and X and G. So it will replace 1 2 3 4 with X. Then we have another replace 5 5 5 1 2 3 4 5 6 7, and we are matching beginning, we negate 0 through 9 and replace that with empty stuff. So negation of 0 to 9 means it will replace everything other than digits. Then we have split to array. So our delimiters are comma and semicolon. So it will split it into 3 element array. Then we have split to table. 1 2 3 should be split, and our delimiter is one or more space characters, so it will replace and make 1 2 3. Then we have substring from ABC 1 2 3 XYZ from 0 to 9. So it will match 0 to 9 and give you the substring. So let me think if I should go more. No, I think this should be enough. So we learned quite a bit, and we will start next video from regex flags 236. And it's quite big file, 236 to 577. 236 to know we should cover a bit more, otherwise the next video will be a bit longer. So we look a bit more. So regex p replace, it's a global replace, so it will be x space space, sorry, x space x. So ABC was there, it matched by ABC, replaced by x. Then we have case insensitive flag, so hello will match hello, or rather replace, it will match hello with hello and then replace that with hi in a case insensitive manner. So there you go. Next is multi-line match. So suppose we have backslash n character, line 1, backslash n, line 2. So by default, all regular expressions match only one line unless you use multi-line mode. For example, in Python, it is backslash m, okay, for multi-line mode. And I think there is another one, multi-line, regex.multiline is there in Python. So we are looking for beginning of the string with line 2. So second line will match here. First line won't match. So we have line 2. Then we have some validation stuff. We have email. So this would require table. We don't have the table. So what we do here is this. This is select example basically. Okay. So you will select email from users table where email is this regex. Note that you should not rely on the regex for email. This regex will miss many cases of email matching. That is, it does not it is not fully compatible with the RFC of email. Phone number is similar, so phone number regex looks like this. Start with plus, so a literal plus if you need to escape with backslash. Otherwise, plus will mean one or more. So it is literal plus, and it should come 0 one time. Then we have 0 through 9. That is either the character should be 0 or 9, one digit. And then we have the reoccurrence of this. Sorry, not one digit. It should be 10 to 15 digits. Okay. Then we have IP4 violation. We select IP, and this should match IP. Again, this IP address example will not work. Okay. This will match 256, for example. Okay. So you should not use it for IP as well. It's not good. Then we have strong password validation. This one is good. So question mark is equal to meaning we will see just in a bit. So let me show you. Question mark is equal to is positive look ahead. Okay. So for example, in this regex, we have question mark is equal to, then we have dot star, and then we have 0 to 9 dot plus. So basically we are looking for 1 to 3, and then we will match anything before that, or rather we are looking in forward direction, left to right direction. So it will match password. So it matches 1 to 3. Okay. So that was the question mark is equal to. So we were here. Okay. So password, what the rule says is we are similarly looking for A to Z. We are looking for small a to z, and we are looking for 0 to 9, and it should be 8 or more. So this look ahead simplifies the fact that capital, small, and digits can occur at any place. All right. Then we have data extraction. So we are extracting 0 to 9 at the beginning of string with 4. So it will extract 2026. Then we have hash Postgres hash SQL hash database, and we want the match with hash and within bracket w plus. So it will extract PostgreSQL and database. So as you can see here, it is extracting PostgreSQL and database. Then we have extract numbers. So here 1, 2, 3, 4 is here, and we want to match 0 to 9 one or more times. So that is also extracted 1, 2, 3, 4. So I think we can end here and cover rest of stuff in the next video. Let me see if we missed anything. No, that is fine. So the best practices about regex. The thing is that regex is kind of something called write only. Okay, what this means is writing is done and it is easier to write, but it is very difficult stuff to read. So if you have watched my Python videos, then you would see that I have made quite large regexes for something like email, phone number, IPs, as well as I believe date. So the date regex, when we did, we found it very complicated. I think date one was complicated. So one of the examples is very complicated. So you might want to go ahead and watch my Python regex parts. There are 5 parts, 5 different videos on regex, starting from easy to increasing difficulty. The thing is that you can do quite a bit of nonsense with regex. So the golden rule of keeping using regex is that keep them simple. If the regex is complex, then look for alternatives. Do not try to be clever and write complex regex. It is not good programming practice. So with this, I will end this video here, and I hope that you have found this video useful, and we will meet again tomorrow in the next video. I know it has been 7 days since I made a video on Postgres. Life caught up with me, so that's why there was delay. So I thank you for watching the video, and I will meet you tomorrow with another Postgres video, that is the second part of this video. And then we will resume our documentation and go through the pattern section of the functions and operators. So once again, thank you for watching the video, and I'll see you in the next one. Enjoy.